Now there's a whole lot of like new notation and vocabulary and stuff that come out of a lesson like this. You know, it's just the beginning, it's an introduction to some stuff. And when we talk about vectors, in the book, most of the time when they represent a vector, they're going to do it with a lowercase letter, like this is let u, right? That means a vector u. In the book, that's boldface, right? And it's clear that it is. You may see it a little bit when I've got it like copied and pasted on the screen here, but if you looked at it in the book, there would be no doubt that that is a bold u, and that means a vector, right? We can't do that as we're taking notes. You can't like, okay, this is going to be bold. And most of the time, the way we write the U so that we know what it means is that we would do this. We would do U and put a little arrow on the top, right? Kind of, it just has the arrowhead only has one side on it. But that tells you that we're talking about vector U. It's not a variable U which just represents one number. It's actually a vector U. Okay, so in this example, they talk about, just as a way to like start talking about vectors, what they're calling a directed line segment. After this, we don't generally mention that again, but a directed line segment would be a line segment that starts at one point, initial point, and ends at another point, which is the terminal point. So in this one here, where they say P equals 0, 0 is an initial point, and Q is 3, 2, right? These are points in the plane. That's the terminal point. That would be from here to here. And if you note, what's directed about it is that it's an arrow. It starts in one place and it goes to the other. Right? And that was told, we were told that's U. V has an initial point of 1, 2, right? And a terminal point of 4, 4. So 1, 2, and 4, 4. And again, this is directed from R to S. There's an arrow at the end of that. Oops. Okay, so, and these are both labeled as vectors. Now, the last thing it says here is, show that these vectors are equal. Show that U equals V. So if they're equal, that means that they have equal magnitudes and equal directions. That's the only thing that will determine whether these things are equal or not. I mean, they're clearly not at the same place in the coordinate plane. I mean, they're two different directed line segments. But vectors don't have a position, right? All they have is a magnitude and a direction. So how do you think we might be able to see, what could we use that would give us some sense of the magnitude of this directed line segment? Say again? A distance formula. Find the length of it. And generally in the coordinate plane, that's how you find the magnitude, right? It's not like wind barbs, you know, where we use little wind barbs and flags and things like that. In the coordinate plane, the longer something is, the bigger the magnitude. How do you tell how long something is? Use the distance formula.